So we've talked about equations using point slope form. We've talked about equations from 2 points. You guys did great on that. We practiced that yesterday. So we're kind of dropping into something a little bit different today with looking at these specific lines, which are parallel lines and our perpendicular lines. This is a 2-day lesson. We'll do half of it today, and then I'm not sure yet whether we'll do the other half tomorrow or on Monday. I haven't decided yet, so I'll make a decision and we'll go from there. So let's look at this notes page. And there are several things that I want to make sure that you do each time. Okay, important things. One thing is when we are graphing, one of the easiest forms to graph from, of course, is our slope-intercept form, which is what these are. So we're looking at these two lines. When I look at this line, what's my slope? So I want you to write that right here. Okay, m equals 2/3, and then I want you to draw your arrow showing the direction that your line is going to be on the graph. For this lesson today, this is super helpful. It really will help you make sure you're getting your lines going in the right direction. What's our y-intercept? 4. So we're going to put b equals 4. Okay, let's look at line 2. What's my slope? 2/3. And what's my y-intercept? -3. Now, when I get ready to graph these lines, what point do we always want to make sure we start at? The y-intercept. Okay, this is.
I thought this is a homework.
You should have had the notes page too.
I know, but I gave it to him because I helped us use it.
Oh, okay. Okay, so let's graph this. First line, we're going to start at +4. So go to +4, put your first point, and then this slope tells us to rise 2, run 3. So when you rise 2, make sure that you run in the correct direction. That's going to give you a line that's going uphill. So think slope dude. We know our line is going to need to be going uphill for a positive slope. And then continue getting as many dots as you can. You're going to get better lines by doing that. And then graph your second line. So for this one, we're going to start at -3. And we're still going to rise 2, run 3, and go in the same direction. So what kind of lines are we ending up with here? Parallel lines. So what do you notice about these, this information that's up here? What do you notice? They have the same slope, okay? So two lines that have the same slope are parallel. These two lines will never intersect, which means cross. The reason that they never intersect, if you think about our slope, in this example, every single time, they're both rising 2, running 3, rising 2, running 3. So they're moving at the same rate. Our slope is our rate, and that's how our graph is changing. And when you have that exact same rate of change, then your slope is going, or your lines are going to end up being parallel. Okay? So let's take a look at our next two examples here. So on our first line, what's our slope?
2.
+2. So let's draw our line going uphill. What's our y-intercept? 5. All right, let's go to our second line. What's our slope?
-1.
And notice that I know when I graph it, this line is going to be going in the opposite direction. So it's important that you make note of this. What's our y-intercept? -1. So let's graph these two lines. So I start at 5, Now, when I think about a slope of 2, what am I thinking when I do rise over run? 2 over 1. Okay, so I'm going to rise 2, run 1. This is a fairly steep line. Remember that the farther the number is from 0, the steeper the line. The closer my numbers are to 0, the flatter the line. So that one is going uphill at a fairly steep angle. This one I'm going to start at positive 1. This time I'm going to rise 1, run 2, but I'm going to make sure when I run that I'm running to the left because I want my line going. I'm not paying any attention to the negative except to know that my line's going in this direction.
The y-intercept.
Oh, sorry. It sure is. That's a good catch. All right, so let's start it in the right place. I'm going to rise 1, and I'm going to run 2 to the left because I want my line to be going negative. Rise 1, run 2. Now, what I would like you to notice on these, notice that if I draw my little right angle symbol right here, that's actually how these lines are meeting at a right angle, a perfectly right angle. So, two lines that intersect at a right angle are perpendicular. And I want us to go back up and I want us to look at the starting place where we started on these lines at the slopes that we had. Okay, so I had a slope of 2 and I had a slope of negative 1/2. Let's think about how those two slopes are different. Okay, there is a flip. Notice that if you were thinking about this as 2 over 1, it flipped and became 1/2. What's that called when we flip it? Reciprocal. What else changed from here to here? The sign changed, right? So what we're going to say is if the slope of the first line is x, the slope of the second line is going to be negative 1 over x. So notice what's happening is the sign is changing and we're taking the reciprocal of whatever our first number was. So the second slope is the negative reciprocal of the first. Now, do you think that means that it's always going to change into a negative? No. What that means is the sign will change. So if you start with a positive, it's going to become a negative, but if you start with a negative, it's going to become a positive, all right? So really what this means is it's going to be the negative of whatever it was, because if I had a negative 2 to start, negative 2 is positive. Remember that the two negatives together would turn it into it. So think about, we're changing the sign and we are taking the reciprocal, which is the flip of whatever the original slope was. Any questions so far on that? Everybody kind of getting the hang of this? These are the two things that really you're going to have to know in this lesson. Same slope. Okay, they have the same slope, they're going to be parallel. If they have the negative reciprocal slope, then they're going to be perpendicular lines. Now think, you guys, if I had, here's my x and y axis, and we're going to talk more about this tomorrow, but you will have something like this, similar to this on your homework, so you might just draw this little guy right here. If I've got some numbers here, so I'm just going to make a few little marks on my graph. If I have a line that is x equals 3, how do I graph that line? Which axis does that cross? the x-axis. Remember, that crosses the x-axis at 3. So I would have a point here, and I would have my line right here. That's x equals 3. And then where would I find y equals 2? What axis would that cross? The y-axis at 2. So this is this line, and this is this line. Are those perpendicular lines? Yes. Okay, so if you have a line that starts with x equals, and you have a line that is y equals, those are going to be perpendicular. What if I had x equals 5?
No.
So how would it be related to this line? Parallel. How would it be related to this line? Perpendicular. Sometimes graphing them helps you be able to see those kind of lines better. So be sure you're thinking about that when you get to that problem on your homework. Okay, so let's flip over to the back. So this says, write the slope that would be parallel and perpendicular to the line given. Right here above parallel, I want you to write same slope. So I'm just writing same. And above perpendicular, I want you to write negative reciprocal. And I'm just abbreviating it. Okay, so I put NEG and then REC. That'll help us as we're thinking about these. So our first example is here. What is the slope of our original line? So put M equals 2. If I have the equation of a line that is parallel to this, what would the slope be? 2. It'd be 2, right? It's exactly the same. So if they're parallel lines, they're going to have exactly the same slope. Now, what happens to the slope of a perpendicular line to this? Negative 1/2. Okay, so I change the sign and I take the reciprocal. I flip it. So 2 over 1 becomes 1 over 2. Let's do the same thing on number 4. So what's my original slope? M equals 2/5. So what would the slope of a line that is parallel be? 2/5. And what would be the slope of a line that is perpendicular? Negative 5/2. Good. So you just flip it over and you change the sign. Now 5 and 6, of course, are not worked out for us. I'm actually going to do it over here because I have more room over here. So I'm going to transfer this one . And what we're going to do is we're going to convert this into our slope-intercept form. So what's the first thing we need to do that? Let's
Add 9x to
Good. Add 9x to both sides. That's exactly right. These cancel because they're a zero pair. And I get negative 3y equals 9x minus 3. What's my next step?
divide by negative 3.
Good. So divide both sides by negative 3. And I get y equals, now here's where you have to split your terms. So I'm going to split and get this term. What is that going to give me? Negative 3x. And then these are going to be my second term. Now these do not cancel out. I have to think about negative 3 divided by negative 3. Positive 1. So this is my new equation. I'm actually going to move that right back over here. Y equals negative 3x plus 1. Okay, so what is my slope? Negative 3. If I have a line that's parallel, what will the slope be? And if I have a line that's perpendicular to this, what will my slope be? Positive 1/3. So sign changes and we take the reciprocal. Okay, so let's do the same thing. I'm going to have you guys do that one over here. So go ahead and convert this to slope-intercept form. think about splitting your terms because you always want to get those split apart when you're writing it in slope-intercept form. Okay, so what's my first term here? 1/3 x. What's my second term? Careful. Negative divided by positive. Isn't this a negative divided by positive here?
No, that's a negative 12.
Oh, is it? Well, I didn't get it copied right, did I? Hey, good catch, guys. All right, you got to do that sometimes. My brain doesn't always catch everything either. So this should be negative 1/3 then, shouldn't it? Right, for our slope?
No, because you subtract 4.
Oh my goodness, okay, here we go. Oh, all right, my brain must be tired from Halloween too. Not really. I can't even use that as an excuse, so no, not really. All right, I'm going to write it over here. So what's our slope?
1/3.
1/3. M equals 1/3. What would a line that's parallel to that, what would the slope be?
1/3.
And if it's perpendicular, it would be -3. All right, -3. Hopefully we got that all right. Now, let's go down to the rest of this. So on number 7, what is the slope of a line that is parallel? What are we looking for? Same or negative reciprocal? Same. So here's our line, y equals -4x minus 3. What would a slope be if it's parallel?
-4.
So let's put m equals -4. This one, what is the slope of a line that is perpendicular? So what's our original slope? So what would our new slope be? M equals -7.
So whenever you're trying to get the perpendicular
Mhm.
slope, how do you know to change the sign? Does it change every single time?
Every single time.
Okay.
So if it's positive, it's going to become negative. Now think about, so if you're graphing a line, I'm going to use my arms here. So if you're graphing a line and you know it's got a positive and it's going to meet perpendicularly, it's going to have a negative. The only time that you're not going to see that, remember, is the one where I talked about where they're going to be flat with your x and y axis. Like the example that we did on the front. Right? So here, I just thought about graphing those because that was actually easier than trying to think about the slope of those lines. Because one here is undefined and one is 0, right? So graph those when you've got those examples, but other than that, the sign's always going to change. So that's a good question. All right, so let's finish these up. So on these, what we're going to do is we're actually going to convert both of these into slope-intercept form, graph them, decide whether they're parallel or perpendicular. So I'm going to have everybody start working on 9 and 10 and 11, and we'll check those together. Okay? So let's go ahead and let's get those converted. And I know it's kind of squeezy for room, so if you need to use the center part, write them there. Try to keep it on your notes page, though, since we'll glue those in our journal. Now, I will tell you at the point that you do this and you rewrite your lines, hopefully you can automatically start thinking about whether your lines are going to be parallel or perpendicular. Anytime you can make that decision before you start graphing, it helps you get the graph done more easily and less mistakes. So you guys on this first one, number 9, what do you notice about the slopes? They're the same, so they're going to be parallel. So as you're graphing it, you should be thinking about your lines going the same direction on your graph. super skinny when you graph them, but they are parallel with the same slope, but they come out super skinny together. Actually pretty hard to get ones that are closer together than that on your graph. When you look at your slopes on number 10, what do you notice?
One's negative, one's
One's negative, one's positive. That should be your first hint, right? Here you have positive 1/3. Here you have -3. Are they negative reciprocals?
yes.
Yes. Okay. That is not it. We have 3 more minutes, and then you get to go. So, okay. So go ahead then and do the last one. On this one, you're just converting them to slope-intercept form, deciding whether they're parallel or perpendicular. Okay, circling those. So we'll finish this one up, and then we'll be done with notes, and I'll show you how we're going to get it in your journal. Okay, on this one, are they parallel or perpendicular? Perpendicular. Okay, questions on this lesson. So the most important things, same slope, parallel, negative reciprocal slopes, perpendicular. What if they don't match either of those? What if I had numbers like this? For my slope. So my first one had a slope of this, and my second one had a slope of this. Would they be parallel? Would they be perpendicular? No. So what we would say about those is these are neither.
Is that what we're learning tomorrow?
No, you're going to have some of the questions like that on your homework. Okay. So it's going to ask you to write in the blank whether the lines are parallel, perpendicular, or neither. And so just test them. If they're not parallel and they're not perpendicular, then they're going to hit this category. All right?
Okay.
But that's basically the gist of this. Here's what I want you to do.